Well, good afternoon. Today will be the first class of the summer school of the Structuralist Development Macroeconomics Research Group. Já está transmitindo? Só fecha esse negocinho pequenininho. É chato. E você consegue levantar essa aba? Okay. Well, good afternoon, people. Let us start with the first class of the summer school of the Structuralist Development Macroeconomics Research Group. The next 2 days, today and tomorrow, I will develop a presentation that begins with the theoretical foundations of the Structuralist Development Macroeconomics. This is the idea that I will do today. And tomorrow I will present a formal growth model that synthesizes many of the propositions of the Structuralist Development Macroeconomics group. Okay, well, here you can see the structure of my presentation. First, let us do a brief overview of neo-developmentalism and structuralist development macroeconomics. Second, I will argue to you that structuralist development macroeconomics can be thought as a synthesis between classical development theory, Latin American structuralism, and post-Keynesian growth theory. Third, that will be the only, we will stop today maybe on the third point. I will present the core propositions of the structuralist development macroeconomics. For tomorrow, I will present the so-called Oreiro, Martins, and Davila Fernandez 2019-2020 model, because there are two versions. One published as a working paper on the Post-Keynesian Economic Society webpage, and another published as paper in Structural Change and Economic Dynamics. The model, I think that the best insight of the model is to show how a country can get stuck in the so-called middle income trap. And then we will end tomorrow with the sixth point, the political economy problem of getting out of a middle income trap. There is a political economy problem that I will tell to you about that, okay? So, well, there is a Brazilian neo-developmentalist school. The Brazilian neo-developmentalist school, also known as Consensus of São Paulo, named by Robert Boyer in 2009 as a preface of a book written by Luis Carlos Bresser Pereira, that has a French edition, but the English edition is Globalization and Competition. I believe that in French will be Globalisation et la Compétition. I'm not very well of French, but I'm just in the beginning. Okay, but well, the Brazilian neo-developmentalist school can be understood as an approach to the deep determinants of economic development, in which macroeconomic policy regime has a key role in explaining the long-term growth differentials among countries, notably middle-income countries. According to Angus Madsen, his famous 1988 article, there is a distinction, an important distinction, between the immediate and deep determinants of economic development. Immediate determinants, well, is the traditional ones considered by economic growth theory, is the existing amount of physical and human capital, the availability of natural resources, the efficiency in the use of existing productive resources, and the level of technical and scientific knowledge existent at a given point of time. Well, regarding the deep determinants, it refers to the reasons why countries differ from each other in the terms of the availability of factors that determine the level of per capita income. Well, the literature about the deep determinants lists some possible deep causes of economic development. One is geography. Another is institutions. That's a Muglo book. I think that's the best representative of this kind of reasoning. Income distribution and economic policy regimes. For neo-developmentalism, economic policy regime is the deep cause of economic development. Okay, the founding father, so to speak, of our school, let me sit a little while. The founding father of our school, okay, saiu? O que eu fiz? Daniel? Eu fiz alguma coisa que está errada. Voltou. Hello? Okay, so let us begin. Restart. Okay, the founding father of the school is Professor Bresser Pereira. The school originated from the seminal works of Bresser Pereira, an article published in 2016 at a journal called São Paulo in Perspectiva. Then a book published in 2007 called Macroeconomia da Stagnação, in English, Macroeconomics of Stagnation, and his 2009 book, Globalization and Competition. Well, in the seminal works, neo-developmentalism is defined as a set of proposals for institutional reforms and economic policies by which the middle developing countries seek to achieve the level of per capita income of developed countries. This recovery strategy is explicitly based on the adoption of an export-led growth regime in which the promotion of exports of manufactured goods induces the acceleration of the pace of capital accumulation and the introduction of technological progress and structural change. For this, the real exchange rate must be maintained at a competitive level in the medium and long term, which requires the design of a macroeconomic policy regime that neutralizes the chronic overvaluation of the real exchange rate observed in these countries as a result of the combined effects of the Dutch disease and foreign capital inflows due to the adoption of the so-called external saving growth strategy that is mainly based in Washington consensus. Well, what's going on here? Daniel, travou. I'm trying. Aconteceu aqui. Okay. Okay, now it works. Well, here there is a picture upside Professor Bresser Pereira and the three fellow guys. It's me, Professor Nelson Marconi, and Professor Paulo Gala. Nelson Marconi and Paulo Gala are from Getúlio Vargas Foundation, São Paulo. Me from University of Brasilia, and Bresser Pereira from University of São Paulo. Bresser was for 3 times state minister in Brazil. In 1987, he was the finance minister. From 1995 to 1998, he was the minister of state reform. And 1999, he was for a brief time minister of science and technology. Okay, we have published 2 books. There is a first one, which is a textbook called Developmental Macroeconomics, Neo-Developmentalism as a Growth Strategy. This book was written by Bresser Pereira, me, and by Nelson Marconi. It's a textbook published by Routledge in 2015. There is another book, is a collection of articles that was delivered in 2 workshops organized by Getúlio Vargas Foundation in 2012 and 2013. This This collection of articles was published in this book, Financial Stability and Growth, Perspectives of Financial Regulation and New Developmentalism, edited by Luis Carlos Bresser Pereira, Ian Craigo, and Leonardo Bulamaki. Okay, so what is New Developmentalism? New Developmentalism is a set of economic proposals for middle-income countries to overcome the middle-income trap and thus make the catching up with higher income countries. Well, basically, New Developmentalism is thought for Latin America countries in the first instance, is thought for Brazil, Argentina, Mexico, Colombia, so on and so forth. But we think that this can be also useful for another middle-income countries. Well, these proposals are based in a new economic theory that we named structuralist development macroeconomics, which can be understood as a synthesis between classical economic development, Latin American structuralism, and post-Keynesian growth and distribution theory. Well, so let us do a brief review about classical development theory. I think that the main issue of the classical development theory is the distinction between a dual and a mature economy. This is made in the classical article of Lewis, Arthur Lewis, that won the Nobel Prize in economics. What is a dual economy? A dual economy, it's an economy with two sectors. And it's very clear this in Brazil. You can see with your own eyes the existence of the dual economy. A dual economy is an economy that have two sectors, a modern or capitalist sector and the traditional or subsistence sector. Well, the subsistence sector employs almost no capital and hence have very low labor productivity. Wages in the subsistence sector are determined by the average productive labor. The modern sector instead employs capital and uses modern techniques developed on high-income countries, so labor productivity is high. The subsistence sector acts as an unlimited supply of labor force for the modern sector. Wages in the modern sector are determined by the subsistence wage plus a premium for labor to accept the harder worker conditions, mainly discipline, of the modern sector. Well, in the classical development theory, it's important to stress there is no Keynesian unemployment. Everyone who is fired from the modern sector can have a job, so to speak, in the subsistence sector. Thus, the relevant economic problem is not aggregate demand efficiency, but structural transformation. Labor had to be transferred from subsistence sector to the modern sector in order to increase average labor productivity and income per capita. And it's important to note that there is, in this model, there is no saving shortage. While there is labor on the subsistence sector, the increase in average productivity made possible by the expansion of the modern sector will be appropriate by profits because wages are given at a subsistence level. Profit share will rise, increasing the average saving rate of the economy. So there is like a Keynesian thought, not exactly Keynesian, but the idea, the classical development theory has this very powerful idea that development creates its own saving. Okay, saving cannot be a restriction to economic development because when you industrialize, when you get your modern sector bigger, so the productivity will increase. Since wages are given, the profits will increase, and using the traditional Ricardian assumption that and Kalekian assumption that saving out of profits is higher than saving out of wages. So if you increase the profit share, you will increase the profit rate, the saving rate of the economy. So development can be no limitation by a shortage of saving. Okay. However, There can be low income traps due to the existence of externalities and increasing returns in the modern sector. The rate of profit will be a positive function of the stock of capital due of increasing returns. So an economy can get stuck in a low income track due to lack incentives for private investment rather than shortage of savings. I think that's the most powerful, one of the most powerful ideas of classical development theory. And is very different from the neoclassical thought. If you are working with a standard neoclassical model, the rate of profit has an inverse relation with the stock of capital. So when you increase the stock of capital, the marginal productivity of capital will be reduced, and so the rate of profit. So poor countries, according to neoclassical theory, are poor because they lack capital, but since they are poor in capital, the rate of profits is very high, according to the neoclassical theory. So the only thing that is necessary for underdeveloped countries to develop is to import savings from the developed countries. And well, developed countries will have interest in export saving because since they have a lot of capital, the rate of return or rate of profit in the developed countries is supposed to be low, while the rate of profit in developing countries is supposed to be high. So if you open your capital account, the capital will flow from developed countries to the developed countries, and development will be, so to speak, automatic. Okay, but this graph is taken from Ross' book of 2013 and shows a possible poverty trap. Here we have on the vertical axis the log of the wage in modern sector, and on the horizontal axis we have the log of the capital in the modern sector. Okay, this inverted L-shaped curve is the real wage paid in the modern sector. The horizontal portion of this curve is occurs when there is labor in the subsistence sector. As soon as not all labor is transferred from the subsistence sector to the modern sector, the real wage is constant, so the curve is flat. But when capital accumulates, economy reaches a point that is called the Lewis point, in which all labor is transferred from subsistence sector to the modern sector, and then wages start to increase as capital accumulates and demand for labor increases, since after the Lewis point, the supply of labor is inelastic, so you have to increase real wages. So you have this inverse L-shaped curve, and you have this positive sloped curve, which is the relation between the stock of capital in the modern sector and the real wage in the modern sector, for which the economy is in steady state. So in this economy, we have three steady states: the steady state S, the steady state U, and steady state M. The steady state S is an equilibrium position in which there is no modern sector. All labor is employed in the subsistence sector. This is a steady state because if the economy is in that point, there is no economic force that will force the economy out of this situation. There is an intermediate steady state U. We can tell that there is the underdeveloped steady state, because in steady state U, we had some a share of the labor force is employed in the modern sector, but another share is still in the subsistence sector. Okay, and we have the steady state M. Steady state M is a situation in which all labor force is employed on the modern sector. As we can see in the graph, the steady state U is an unstable equilibrium, which means that if the capital stock is just a little lower than LNKU, then the economy will return to the steady state S, okay? In order for have a self-sustained economic development, the economy must accumulate a threshold level of capital, which is LNKU. That formalizes the idea of Hirschman, of a big push. You know, the economy must accumulate some threshold level of capital stock in order to have a self-sustained economic development. This means, in practical terms, that development, mainly in its first stage, must be state-led, because private sector will not have the coordination capabilities of deciding to invest the minimum quantity of capital, KU, in order to have a self-sustained development process. Okay, well, Latin American structuralism. The magnum opus of the Latin American structuralism was the Prebisch 1949 essay that was named Manifesto Latinoamericano, Latin American Manifest, that was republished in 1986 after Prebisch died. The original name of the article, I will write in Spanish, El desarrollo económico de la América Latina y algunos de sus principales problemas. The economic development of Latin America and some of its main problems. This version, after Prebisch's death, was published in the journal Desarrollo Económico. Well, what are the vision of Prebisch? For Prebisch, structural change is understood as industrialization, which means increasing the participation of manufacturing employment in the total employment, and is a necessary condition, although not sufficient, for a sustained increase in the standard of living of Latin American countries. Okay, what is the major obstacle for industrialization in Latin America? Is the international division of labor and the role of Latin American countries in it. Prebisch developed the idea of a center-periphery nexus. The center countries, which now we name the developed countries or high-income countries, had an homogeneous and diversified structure of production, which means that labor productivity is similar through different sectors and activities, and these countries produce and export many types of different goods. Say, for instance, Germany. Germany has a very diversified set of exports, and the productivity differences between sectors in Germany is very small. Okay, technological progress is originated in central economies in these countries and then spread to the peripheral countries. Technological progress in these countries result in center countries, result, at least to the 70s, result in higher wages and hence in constant export prices. Well, peripheral countries like Brazil, Argentina, and so on, had a productive structure which is heterogeneous and specialized at the same time. These countries had a small modern export sector, specialized in produce and export primary goods for the central countries, and a large subsistence sector. There are large differences in labor productivity between sectors, and exports had a low income elasticity. Technological progress incorporated in the primary sector results in a reduction of prices of export goods. So That's why we have the deterioration in terms of trade. Deterioration in terms of trade makes the fruits of technological progress in the peripheral countries to be appropriated by central countries. This is the origin of uneven growth. Well, here there is a table that is from Prebish's original article. Prebish calculated the terms of trade in Latin America from 1876 to 1947. So he set base 100 in the period 1876 to 1808. So you can see that in the beginning of the 20th century, the terms of trade began to deteriorate, and it deteriorated a lot during the period from 1921 to 1925. When we compare this period with the period of 1876 to 1880, there is almost 33% of the deterioration of decrease in the terms of trade. Okay, and the terms of trade at just the end of the Second World War is almost 30% lower than in the period of 1876 to 1880. Okay, now post-Keynesian growth theory. According to Calder, well, Calder 1988 is a chapter book and a book edited by Alain Baher. I think that Calder died in 1886, so it's a post that article published in honor of Calder. But according to Calder, the rate of creation of productive resources is determined by the rate of expansion of aggregate demand, more specifically by the expansion of those components of aggregate demand that are autonomous in relation to the level and or to the change of output and income. The investment rate adjusts itself in the long run to make the warranted rate of growth compatible with the growth rate of non-capacity generating autonomous demand. Two sources of non-capacity generating autonomous demand. We have government spending or exports. Well, Thoreau, in his famous 2002 books, tell to us that exports is the only true source of autonomous demand in the economic system, since it's the only one that is true exogenous. And the article published in Cambridge Journal of Economics by Thoreau and Ledesma, the natural growth rate is made endogenous, since productivity growth depends on the rate of capital accumulation, which is led by growth of autonomous demand, and the rate of growth of manufacturing output, which depends on the growth rate of exports. Well, the Thoreau's law, well, unfortunately, there is not appearing on the slide, but the Thoreau's law is the formalization of this kind of reasoning. You know, the Thoreau's law established the following idea, that the growth rate, domestic rate of growth that is compatible with the equilibrium, the balance of payments, is equal to the ratio of income elasticity of exports and income elasticity of imports, both multiplied by the growth rate of world's output. Okay. So we have this, so we make a brief review of these three theoretical traditions: the classical development theory, the Latin American structuralism, and the post-Keynesian demand-led growth model. For me, the best representative of the post-Keynesian demand-led growth model is the Thoreau model. Okay, well, but what is exactly structuralist development macroeconomics? Usually, economic textbooks treat separately macroeconomics, which is seen as the study of cyclical fluctuations in economic development, seen as the study of the long-term trend of capitalist economies. However, recent developments in the econometrics of time series had shown that it is incorrect that the composition of real output behavior in trend and cycle. This is because the time series for the gross domestic product, both for developed and developing countries, presents so-called unit roots, so that temporary shocks in demand or supply have permanent effects over current output. Thus, the cyclical component of economic activity, traditionally associated with the variations of aggregate demand in the short term, affects the growth trends of capitalist economies in the long term. In this context, the growth trend becomes dependent on the trajectory that the capitalist economies effectively described over time. This phenomenon is known in the literature as path dependence. Well, it is therefore reasonable, it is not therefore reasonable to separate macroeconomics from the theory of economic development. More reasonable is to unite the two areas under the name of macroeconomics of development. But as our vision of economic development is a structuralist vision, what we will introduce here is a structuralist development macroeconomics that can be defined as follows: is the economic theory that explains economic development as a historical process of capital accumulation with the incorporation of technological progress and structural change, in which the accumulation depends on the existence of profitable investment opportunities offered by the sustained growth of demand, which on its turn depends on the even increase of the domestic market and also of exports. Okay, so here is the core principles of structuralist development macroeconomics. First, the rate of economic growth in the long term is determined by the growth rate of exports. In the short and the medium term, of course, you have fluctuations in other components of aggregate demand that matters for real output, but in the long run, the rate of economic growth is determined by the growth rate of exports. The growth rate of labor productivity depends on both the growth rate of real output and the manufacturing share. So the natural growth rate is endogenous. The ratio of exports and import elasticities is not constant over time as in Tyrrell model, but depends on the manufacturing share. So the balance of payments constrained growth is endogenous. The dynamic of manufacturing share depends both on price competitiveness, which means real exchange rate, as well as in non-price competitiveness, mainly the technological gap that is explored in the evolutionary literature of economic development. The level of real exchange rate for which the manufacturing share is constant over time is defined by us as the industrial equilibrium exchange rate. The level of real exchange rate for which the current account is at balance is the current account equilibrium exchange rate. Now, I think there's the most known principle of structuralist development macroeconomics, which is the Dutch disease. The existence of cheap natural resources can make industrial equilibrium exchange rate higher than current account equilibrium exchange rate due to the Ricardian rents generated by the exploration of natural resources. The real exchange rate compatible with a reasonable rate of profit in the manufacturing sector is much higher depreciated than the one in the primary sector. This is what is called Dutch disease. Okay, I'm just finishing my presentation for today. Actual real exchange rate can be lower than the current account equilibrium exchange rate due to the adoption of a growth with foreign saving model. So let me clarify this issue. According to structuralist development macroeconomics, there are two independent sources of real exchange rate appreciation. The first one is the Dutch disease. Another one is the foreign saving, the growth with foreign savings model, which is a model of growth model based on Washington consensus that presupposes the liberalization of capital accounts, okay, in order to import saving from the rich countries. So the idea is that if you combine both the Dutch disease and the liberalization of capital accounts, your real exchange rate will not be only appreciated regarding the industrial equilibrium exchange rate, but also regarding the current equilibrium exchange rate. When you have both sources of real exchange rate appreciation at the same time, you will have premature industrialization and balance of payment crisis, okay? So the foreign saving model is based on the Washington consensus and establishes that middle-income countries need foreign saving to increase their investment rate and hence growth at a higher pace. This model assumes that foreign and domestic savings are complementary one to another. Structuralist development macroeconomics, on the other way, says that foreign and domestic savings are substitutes. In order to attract foreign savings, it is necessary to appreciate the real exchange rate, which will result in an increase in the wage share and hence a reduction in the domestic saving rate, since propensity to save out of profits is higher than the propensity to save out of wages. Moreover, to attract foreign saving is necessary to set domestic interest rate at a level higher than the one given by uncovered interest rate parity, given by international interest rate plus country risk premium. Middle income trap occurs in countries that suffer both from Dutch disease and adapt the foreign saving model. In order to get rid of the middle income trap, a country may have a competitive real exchange rate, which requires first to set the domestic interest rate at a level compatible with the uncovered interest parity, and two, neutralize Dutch disease by taxes over exports of primary goods and adoption of a managed floating exchange rate disease. If a country is successful in neutralizing the Dutch disease, then it will run with a small current account surplus. Well, this is for today. We have 10 minutes. We can open for questions from the public. Many thanks. Anyone? Okay, give to him the.
Yeah, thanks for this very lucid presentation of the core principles. So while you're presenting, I was thinking that the only channel that you adopt is the real exchange rate channel in the mind. The issue of developing countries is, that kind of real exchange rate channel kind of assumes a uniform sectoral conception. Now, if you have a developing country which the two sectors, subsistence and modern sector, or formal and informal sector, in fact, you could actually, instead of raising the wages, you can raise wages in the formal sector at the expense of informal sector, at the same time keeping the real exchange rate constant. This dynamic between formal and informal, which I think is quite structural in developing countries, is not captured by the purely real exchange rate mechanism that you articulated in this model. So I'm kind of wondering, is there a way to capture that duality?
Eu tenho uma pergunta.
Yes, of course. In English, please.
Professor, I have some questions regarding also the level of the equilibrium real exchange rate.
Industrial equilibrium, exchange
Yes.
rate, okay.
In my view, and it's a question, I'm not sure if I'm right, but you can have a real exchange rate that is disequilibrium rate, but you can have effects like, for example, in the distribution of the share between the manufacturing industry, like, for example, high technological industries may lose some competitiveness because they import a lot also. So how would you respond to that? And yes, that's it. I also, something I already mentioned, in our country, for example, in Brazil, we have this political problem in the meantime of devaluating the real exchange rate. And this is a big problem when you look at this vision as any strategy of development, because someone has to devalue, some government has to devalue the exchange rate, and this government normally doesn't win the next election.
Okay. Mark, yeah. Oslin.
Thank you very much. It's of course very privileged to hear about new developmentalist economists from you as being one of the key thinkers, authors on that. I would like to ask your opinion about where do things like land reform, public investment, credit rationing, sit in this framework. Also with respect to exchange rate. Now, when I think about Korean developmentalist state, it was always about multiple exchange rates, similarly multiple interest rates, using state to steer the economy. So where do these sit in your new structuralist, developmentalist macroeconomics?
Okay, thank you very much. Well, starting with the question raised by Hagaf, well, the experience, well, this theory, the new developmentalist, is a historical based theory, okay? It's not axiomatic, so on and so forth. So it's based mainly on the experience of Latin American countries, mainly Brazil and Argentina, okay? So what we saw in Brazil and Argentina in the last 40 years, we saw, well, Argentina, I believe, is still 50 or 60 years. In Latin America, since the 70s, we are always committing the same mistake together once and once, which is to allow the real exchange rate to appreciate. Argentina and Chile allowed this in the 70s, Brazil not, okay? So they have strong financial problems in the 80s that we did not. They have a banking problem, but we did not. We have an external debt problem, but the nature of our external debt problem is a little different from, say, Argentina, Chile, and Mexico, because yes, in the 70s, we accumulate a lot of external debt, but we accumulate to invest, okay? Argentina and other countries accumulate a lot of external debt, but in order to finance consumption. So it's a different, completely different situation. So Brazil responds to the external debt crisis in a different way than Argentina or Mexico, or so on and so forth. For me, it's very weird that the first country to default in Latin America was Mexico, Mexico is an oil exporter. How can an oil exporter can default? For me, it's insane. Brazil did not default in 1982. It defaulted in 1987, but it's another story, okay? But for us, the 80s was the lost decade for us Brazilians, okay? Because we have reduced low growth in the 80s, low compared to the growth rate of 50s, 60s, and 70s. And we have very high inflation. So in 1989, when we have our first presidential elections after the dictatorship, a guy named Fernando Collor de Mello win the elections and adopted a liberal program. He told to the Brazilian people that the cause of our diseases was excessive state. So he liberalized the economy, so reduced the import tariffs. He privatized companies, and he tried to resolve the high inflation problem, but he didn't. So he was impeached. Then assumes the vice president, Itamar Franco, and he invited Fernando Henrique Cardoso to be the finance minister, and the real plan begins. Okay, but in the 90s, we have this combination of open the economy for international trade, reducing tariffs, and with the real plan, we have a huge appreciation of real exchange rate, more or less 30% from 1993 to 1995. 30% in just 2 years, okay? Well, with the combination of open the economy for imported goods with the real exchange rate appreciation was a mortal attack against the Brazilian manufacturing industry. Our process of premature deindustrialization begins in the 90s. And what we saw a lot of people that had good jobs and formal markets, you know, in the 90s, they tried to open their own enterprises. I think that people that are a little more older must remember the famous stores of $1.99, when you can buy goods imported from China by almost $2 at that time, but that's $2, you know. So a lot of people that lost their jobs in the manufacturing industry try to become self-employed and open this shoppings that you can import now because of the reduction of import tariffs, and a lot of stores of $1.99 open in Rio de Janeiro, São Paulo, so on and so forth. But they eventually bankrupted. So the quality of employment starts to deteriorate in the 90s. So during the Fernando Cardoso administration, the real rate of economic growth was very low, just 2.5% per year. When you compare with our average growth rate from 1950 to 1979, which is 7% per year, it's very low growth. So in the beginning of the 21st century, Lula wins the election, and he started some programs of social assistance, increasing the minimum wage and so on and so forth. But before his government, before he assumes the government, there is a huge depreciation of nominal exchange rate, more than 30%. Then in the beginning of Lula government, we have a very competitive real exchange rate. So exports of manufacturing goods just skyrocket in 2003 and 2004. From 2003 to 2007, Brazil have a current account surplus of more or less 1.5% of GDP in the average of this period. So in this brief period that we for a divine coincidence, we have competitive real exchange rates. We have a government that restart public investment and adopted more social assistance programs. We combined an increase in domestic demand with an increase in foreign demand, and the country starts to accelerate economic growth. The problem was the monetary policy. Okay, from 2003 to 2006, very, very high interest rates were maintained by the central bank. So the nominal exchange rate, which are competitive in 2003, or no so longer competitive in 2006. So we have the 2008 financial crisis. We can recover very quickly from that, but from 2010 on, our manufacturing output simply stopped to grow. We stagnated our industry until 2014, when we have our economic crisis, and then the manufacturing output just decreased. Nowadays, which means 2023, the output level of Brazilian manufacturing industry is equivalent to the level of 2004. Okay, 20 years of stagnation in manufacturing output. So we can see, based on our history, that a real exchange rate overvaluation is mortal for manufacturing industry. And these have consequences over the informal unemployment. In the beginning of the 21st century, 60%, more or less 60 to 65% of all labor force was employed in the formal sector. Today, less than 50%. So the quality of employment had reduced too much because of our premature industrialization. So, of course, that making the real exchange rate competitive will not solve the problem of the informal sector, but is absolutely necessary to avoid the complete destruction of the formal good employment that rests in this economy, and to start the reindustrialization process. For now, our real exchange rate is more or less competitive. We start to appreciate again because of very high nominal short-term interest rates. But I think that in the case of Brazil, and that I also think the case of Argentina, let us discuss tomorrow, but I think that the case of Brazil and the case of Argentina shows that real exchange rate is mortal for economic development, because it just killed the manufacturing industry, and without the manufacturing industry, you simply can have no hope for development. Okay, well, regarding the question of Onaran, Özlem, of course, that exchange rate is not enough to solve economic development. So public investment is absolutely fundamental to any country to develop. And by now, we are at the lowest level of public investment in our history. After 2 years of Temer government and 4 years of Bolsonaro government, because of the so-called expenditure ceiling rule that freezes the government expenditure in real terms since 2016, the public investment is now lower than 1% of GDP. It's very, very low. During our golden age, the public investment was 7% of GDP. So you can see that that's a lot of things. Okay, regarding the credit rationing, I think that Brazil had the instruments to make credit available for all Brazilians, but we still have many Brazilians that do not have a banking account. So, but we have public banks. We have Bank of Brazil, Banco do Brasil, in Caixa Econômica Federal. So I can think that these public banks can be and should be used to give a greater access of people to demand deposits and also for credit for their small business and so on and so forth. So regarding the last question of Danielle, because I think that we are now just in time. For Danielle, for high-tech industries, real exchange rate is not so important. See, we had a huge appreciation of a real exchange rate, but Embraer business are not damaged, okay? But for medium and low-tech industries, overvalued exchange rate is absolutely fundamental. If you have real overvaluation of exchange rate, this will simply kill your low and medium tech manufacturing industries. Okay, now regarding the most controversial issue of neodevelopmentalism is the relation between real exchange rate and income distribution. I think that most of the critics of neodevelopmentalism did not understand that an overvalued real exchange rate is a non-sustainable real exchange rate. This means that sooner or later, if you have a real an overvalued exchange rate, you will have a balance of payment crisis. Even if you do not have a balance of payment crisis, you have premature deindustrialization. If you have premature deindustrialization, this means that people will lose their jobs on the sector that pays higher wages and have to make a living in the informal sector that pays lower wages. So overvalued exchange rate is not a solution for the problem of income distribution. We will not get higher wage share in income with this kind of strategy, because sooner or later, these people that are working in good jobs, say like engineers, if you do not have manufacturing industry, where engineers are supposed to work? As Uber drivers? I'm telling in the car here for Hagav and Gabriel that an engineer that in 2010 was working in the construction sector and makes 10,000 and 12,000 reais. After the crisis of 2014, got unemployed and had to rent a car and act as a Uber driver to make 3,000 or 4,000 reais. So the problem of the idea that, no, let us make real exchange rate overvaluated because the overvaluation of a real exchange rate will increase real wages, and an increase in real wages given productivity level, average productivity level, will increase the wage share. Well, this is a completely nonsense, because the real exchange rate will deindustrialize the economy, and with the industrialization, the average productivity of the economy will be lower, because you transfer labor from the high productivity sector to low productivity sector. And doing that, the wages will also be reduced, not by price increases, but because when people are fired from good jobs in the manufacturing sector, they will be hired, if they can achieve that, by firms in the service sector that pay lower wages. So real wages will fall. So that is not a solution. Okay, so people, just 5 minutes of rest. I will take Giulio Guarini that is in my office, and so we will start Oh, we have a coffee break. We have a coffee break now. Fica a sessão mesmo. Consigo. Aí você abre aí. Abre. Ah, não, consigo. Ah, não, tudo bem.
Eu entrei pelo site aqui, ó, eu mando logo.
Julio, what is the file that you need? Okay. I will send it to him and we will solve the problem. Okay? Não, já. Ah, peraí, já vou te mandar. No teu WhatsApp, né? Só que tem Soares, esse aqui, né? Tá? Aí você vai abrir o arquivo que está escrito tem 4 arquivos aí, esse aqui, ó. Esse aqui, tá? Deixa eu comer aqui um pouco.
Aí você vai apertar Alt, não. F11 aqui, ó. Aí na hora de projetar aqui, nós vamos fazer aqui, ó. Aqui, ó, e selecionar isso. Tá? E aí, é isso, né, professor?
Oi?
É essa apresentação depois.
Julio, is this your presentation? Yes.
Principal aqui, ó. Vai vir aqui.
Só querendo lembrar que, para quem quiser, eu estou vendendo os exemplares do meu livro, Macrodinâmica Pós-Keynesiana e Macroeconomia do Desenvolvimento. Macroeconomia Pós-Keynesiana por R$ 70 e o Macroeconomia do Desenvolvimento por R$ 100, eu aceito Pix. Tá? Ok. Tarcísio, eu quero...
Passa.
Aqui, ó. Será que não é que because we think that the equation is not so. Right?
Yes, I think it's sort of about this file. Do you have the presentation? No. Oh my God, why? Yeah, because I finished my presentation of this of the Aurelio that he. No, because it's the job. You can rotate, but it's the old computer. Yeah. Yes, but you could transfer. Yes. But I'm only because I she did this. But now it's impossible to speak. Oh my God. So come back to the PowerPoint. This PowerPoint. Why you don't use now? Why you open this this version? You have to open because you are not managing. You know, open resource. Yes, PowerPoint. No, sorry. Come back to the mail, please. Come back to the mail and put. It's okay. Close the file. Okay. What? No, but it is not PowerPoint. Why? Why you don't use it? Have you come? No. Libre. This is a problem of Libre. Come back. No. No, come back. Come back to the main, please. This is not PowerPoint. Please come back to the main. Email. And one moment. Sorry. This, no, I think that you have to open. The problem is that why we open in
Show the folder. Yes. And now
why
is there.
okay. But no, why Libre?
Maybe
It's not PowerPoint. Not sorry, but this morning was use this computer.
Yeah. Right.
Something someone changed the yeah, because it's not problem of equation, but it's the same. But you have to connect this. But it's the same. In this computer, this is not PowerPoint. But no, you have to connect this.
Yes.
But it's possible.
Right.
I think also PDF would be the problem. The problem. I think you have to possibly from the key. Yes. When she opened the equation will appear. When she appeared and sent to the computer, But also PDF is computer have not PDF original and allowed to be. Because it needs the operations by doing. Okay.
Não, eu vou salvar aqui.
So now I think the remain the problem if you take this. Yeah, because this now we have to go to the email. We have to send okay, so send to you.
Yeah. But he has to pick right.
It's for
Eu acho que vai fazer não.
não vai ver.
Dropbox. Okay, only this. No. Yes. Okay, save the PDF. Check.
Okay.
PDF. At the beginning, we use Libre or other. The problem but there is very problem connection with the other kind of problem. Or the alternative alone is impossible. Together is possible. Otherwise, it's a problem failure of communication. Yeah. Or all decide to have Libre or not.
Yeah.
One or two is impossible. I know it's
We don't have to use some information.
also if you consider fields
Yeah.
with Excel from Excel. Right?
Okay.
Only to see all. Sorry. Okay.
Okay. Perfect. All right.
Okay. Yes, of course. Nice to meet you. No, it's the first time. Yes. Sorry? Yes. You are Facebook. Yeah. Só que na hora de fazer a projeção, tem que compartilhar. Já vou abrir agora. Agora eu fiz em látex. Como posso fiz? Eu sento aqui.
A gente não vai compartilhar a tela.
Eles só vão isso aí.
Yeah, because of the slide. Yeah. Because you must start. It's working, right?
Ô, Daniel, tá funcionando isso aqui? Isso. Tá, beleza.
Can start. Okay. Yeah, I'm waiting the live stream, so already on. All right. Okay, good afternoon. Good afternoon, everyone. I would like to welcome all of you, those present here in person, as well as those following us online, to the first special session of the third international workshop of the Structures Development Macroeconomic Research Group. This year, as you know, the workshop is a joint initiative with the Institute of Applied Economic Research, IPEA, and the Economics Department of the University of Brasilia, with the support of PCTech ONIBE and the Regional Council of Economics of the Federal District and the State of Guayas, as well as the Federal Council of Economics and the National Council for Scientific and Technological Development. So many thanks for all those involving in making this workshop possible. Before we start, let me introduce myself. My name is Sulafa Nofal. I am a researcher and a member of the Structures Development Macroeconomic Research Group, led by Professor José Luis Oreiro. And I will be moderating the special session today. This session, as you know, is part of 3 days workshop dedicated to discussing the new developmentalism, public policy for innovation, social inclusion, and environmental sustainability. So it's a great pleasure for me to be part of it and to introduce our speakers today, who is going to talk about a very important and urgent issue regarding climate change and new developmentalism. So the session, in fact, as the title indicates, raises a very important question, which is, do we still have time to avoid global catastrophe? So we have a great panel to address this question. So please join me in welcoming our two distinguished speakers. We are lucky to have Professor Tarcísio Rocha Filho. Professor Tarcísio holds a PhD in physical sciences from Free University of Brussels. He is currently a full professor at the University of Brasilia. He has experience in physics with emphasis on mathematical method of physics, work on a range of important topics such as nonlinear dynamics, non-equilibrium statistical mechanics, analytical properties of nonlinear equation, and numerical and algebraic computation. His scholarly contributions have appeared in journals including Physical Review and International Journal of Modern Physics. So thank you very much, Professor, for joining us. We are lucky also to have Professor Giulio Guerini from Italy. Professor Giulio is he is a professor at Tuscia University, Italy, holds a PhD in economics from the University of Rome La Sapienza. He has been visiting scholar at prestigious institutions such as University of Oxford and Sussex, extensively contributing to the literature of ecological economics and sustainable development. His scholarly paper appeared in top journals such as Research Policy, Ecological Economics, Social Indicators Research, Oxford Development Study, and many others. So thank you very much for being with us. So we will start the session with a presentation from Professor Tarcisio. After that, we will have presentation of, by Professor Guerini. And after that, we will open the floor for your questions and comments. So Professor Tarcisio.
Better here. So I will try to present to you try to explain shortly what is climate change, what causes it, what's happening, and what are the possible solutions and what are the limitations of these possible solutions. Well, the first thing we have to speak is about the evidence for empirical evidence for climate change. Here we have a graph of the average temperature on Earth. Here we have the evidence collected for the average temperature on Earth the last many thousands years. So we have here is the last glaciations, then the temperature rose and stayed relatively stable until very recent times. And this began with the Industrial Revolution. Here we have many estimates of the temperature, and recent times an exponential, very rapid growth. Here is also the variation of this temperature over recent times. So it's obvious that the average temperature on Earth raised. Well, the next question is why? And this is caused by what everyone calls greenhouse effect, which is the accumulation of gases that trap radiation emitted from Earth, as we will see. And the main responsible is oil, sorry, but we have CO2 emissions by oil, gas, and all the cement, production of cement, coal, and the total emission of CO2. And we see that by the middle of the 19th century, it grows very rapidly. It grows very rapidly. Okay. So there are also many different greenhouse gases behind CO2 is methane, nitrous oxides, fluoride gases. And one of the main greenhouse gases is water. But water is good, so we don't speak about water here. We need water, but we don't need all these other gases. Oops. So here we have the different sources of gas emission. I think I will stay here because I can read it better. So we have different types of emissions. You can see the hand is so easy. Carbon dioxide is by far the principal greenhouse gas, not the only one, but 65% of the greenhouse gas emissions for carbon dioxide from fossil fuel and industrial processes. And a little part comes from land usage and methane, nitrous oxide, and fluoride gases. And here we have the different emissions by sector. So we see that electricity and heat production responds for 1/4 of the greenhouse gases emissions. The rest is from industry, agricultural sector, transportation, cars, trucks, boats, airplanes, etc., for production of buildings and from other energy sources. Then I will explain now what is the greenhouse effect. is essentially that the natural greenhouse effects, I will show you briefly. The sun emits radiation. The earth absorbs a part of this radiation. A little part is reflected by the earth. This is called the albedo effect. And another part, which is not, enters the atmosphere, is trapped by the earth, and the earth re-emits some radiation. This radiation, a part goes into space, another part comes back and is absorbed in the atmosphere by the excess of greenhouse gases. And here we have, I show briefly, the radiation from the sun in black, from the earth in red. This is the black body radiation. That means a body that absorbs all light, all radiation, electromagnetic radiation it receives, and it emits this radiation, and the radiation it emits depends on its temperature. So here we have the wavelength. For the sun, it emits in this range, which essentially, obviously, the visible light also emits in the infrared a little bit and in short wavelength. And in red is the earth. The earth, it emits in greater wavelength, higher wavelength, which is essentially infrared, okay? Because it's beyond the red. And this happens because the sun, the surface of the sun is about 6,000 degrees. But the surface of the earth, in average, is 15 degrees centigrade, okay? So the earth absorbs the radiation and re-emits this radiation in a different form, different wavelength, which these greenhouse gases can absorb and re-emit. So it traps this radiation. So we can do a very simple calculations using what we learn in physics, undergraduate physics, is essentially that the sun receives, the earth receives radiation from the sun. We know that the radiation emitted per unit area for a black body, which is the earth and the sun is approximately that, is proportional to the temperature in Kelvin to the fourth power. And they have this sigma here, is called the Stefan-Boltzmann constant. It's a calculation we do in physics. And we know that the total income radiation from the sun, just above the surface, the atmosphere of the earth, is 1,300 watts per square meter. So, but you have to remember the earth is a sphere. The radiation received is the cross section of the sphere. We do some calculations. A part of this radiation is re-emitted by earth, which is the albedo effect, which more or less a third of this radiation. And if we do the computations here, what will be the equilibrium, the state of equilibrium where the temperature doesn't change? If we compute this without considering the atmosphere, the average temperature of the earth would be minus 18 degrees centigrade. But the real number is 14. So what's the difference? The missing element here is the greenhouse effects, the atmosphere. So we know that the atmosphere, it absorbs a fraction of the re-emitted energy by the earth. We call it epsilon. This is computable, which is the order of 0.75% in fact, and we redo the calculations using the energy balance. You receive energy, you emit energy, you say the temperature must be constant, and we conclude that it must be 13 degrees centigrade, which is very close to the real value. But this is a very, 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 very simple atmospheric model. Today, the models used are much more complex in space, in a space grid, with different levels of atmosphere and so on. But this is just to give an idea why greenhouse gases are very, very important. So if we put more greenhouse gases in the atmosphere, it will trap more radiation and the earth temperature will rise. So here we have, this is from the IPCC panel, the last one, the effects on Earth for different average temperatures. So today we are more or less 1 to 1.5 degrees of increase in average temperature. So here we have the annual hottest days, temperature change all around the globe. The mean total column soil moisture, water on the soil, it's important for plants and agriculture. And annual wettest day precipitation change when it rains more. So what we can see, we have, if we go from 1.5 degrees to 2 degrees, there are already significant changes. If we go to 3 or 4, it's a complete disaster. We see here in Brazil, and it will be very hot. And precipitation will, in South America, in most parts of the United States, will become dry. Here, mainly in the Amazon forest. It will rain a little bit more in the Sahara. But we see that the effects on the climate, not only temperature, but precipitation, moisture are very important. And we see here the precipitation change. We have very strong rains. Other parts will have a lower rain. And the consequences are also, other consequences is risk of species losses. The same kind of maps for 1.5, which closer up we are now, 2 degrees, 3 and 4 degrees. So many species will be lost, risk to human health. So we see that, well, us in Brazil, we're quite doomed. Africa, Southeast Asia, most of the world will be suffering with health, very strong increase in health risk. Food production will be, of course, impacted. The yield in maize, corn, it is a major step here in Brazil. We see that it will be sensitive, reduced by, in some places, by something like a third. Fisheries yield, and it's good to remember that about, if I remember well, half of the fish we eat in the world comes from fish farms, not directly from seeds. So this will be impacted also very significantly. So we will have problems with food production. Okay. Another consequence is the sea level. Well, here I show a graph that starts in 1880. The end of the 19th century, we have a raising more than 20 centimeters of sea level. And this will continue for centuries because the sea, it doesn't respond instantaneously to increase in temperature. It takes time to absorb the energy. And when you heat the water above 4 degrees centigrade, it expands. So you have the same amount of water, but it fills a higher volume. And plus, there is also the water that comes from glaciers, some ice trapped in other parts that contribute to this effect. So even if we produce no more carbon today, it would take centuries for the rising sea to stabilize. This is another big problem. And we have some future scenarios that also from the International Panel from Climate Change, from the last one. What happens in greenhouse gas emissions? If we limit warming to 1.5, we have to decrease enormously, a huge amount, the emission of CO2 for 2 degrees also, but a little bit less. And the present implemented policies will stabilize more or less the current emission. These regions are just uncertainty gaps in the models. But the predictions is a warming by the end of the century of 3.2 degrees, with all the consequences we saw, if we maintain current policies. Okay. So this is for current emissions of greenhouse gases. Here it's the same thing for CO2 and methane emissions. So what we see is that the current policies will only stabilize more or less the current emissions of greenhouse gases. Okay, which is another point I think is very important is who's responsible for that, and the responsible is just one guy, the exponential function, which is the enemy of humankind. What's the problem with the exponential function? Is the function that grows faster than anything you can imagine. Even an economic growth of 0.1% per year on the planet will give you an exponential function. So I think I present here the GDP per capita of corrected by inflation, et cetera, for England, which has a very long series of data. It begins in 1270 here. And something special happened in 1642. A special year in the history of humankind, because the year Galileo died, and the same year that Newton was born, which is a mark in scientific development. We can say that scientific revolution commences more or less at this moment. And from then on, we see an exponential growth of income per capita of people. Of course, the level of life incremented with it, but it has also other consequences. This is the global energy consumption according to different sources. Traditional biomass, well, it stay more or less at the levels of 18th century. But we started to use a lot of coal, oil, natural gas, a little bit of hydropower, solar, a tiny bit, modern biofuels, and other renewables. But we see this is a typical exponential function. And since we are in academia, the number of scientific publications also follow an exponential law. This is a monologue graph from 1700s till today, different sources, with a natural growth rate of 4.1% of the number of papers each year after March. So we have also an exponential growth of knowledge, scientific knowledge, which is the scientific revolution, which allows us to control nature and use the nature for our interests. That's the idea of science. And also world population, which has an enormous growth, mainly due to advancements of scientific and medicine and the possibility to exploit nature to give us what we want, what we need, food, etc., etc. And some projections according to different scenarios. Apparently, the number of human beings will stabilize in the second half of this century. I hope to see it, I don't know, but the problem is here. The size of our planet remains always the same. So we must fit an exponential inside something finite, and this is impossible. At some moment in time, it will just not fit. And I think we are starting to see the consequences of it right now. For instance, world oil and gas reserves, the confirmed ones, we see that it has grown a little bit, mainly not of the discoveries of new great reserves, but because they estimate the size of current reserves, okay? And with a little a tendency of becoming constant, even a little decrease recently. So the estimation is that at current usage of oil, all current reserves will be depleted in 40 to 50 years. Okay, for oil. For natural gas, which is 7,000 trillion cubic feet, this will last at current use something like 50 to 60 years. Okay, and the younger people here will be alive to witness this, what will happen. Another point important is that the excess of CO2 that was already emitted by us in the atmosphere, even if we start producing, if the whole humanity disappears, it will remain in the atmosphere for another 300 to 1,000 years. It stays there. for a long time before being absorbed by plants, the ocean, etc., etc. Half-life of methane is much short, is around 12 years. Nitrous oxide is its lifetime is 114 years. In fluoride gases, it's just a month, depending of the gas, specific months to thousands of years. So the problem just doesn't disappear overnight, even we stop producing greenhouse gases. So what we must do, there are only two things we must do, is stop producing CO2 and other greenhouse gases and try to remove those gases that we put on the atmosphere. Both are possible. I'll explain how in the limitations for that. Well, first of all, the production of greenhouse gases varies greatly among countries. Here we have the electricity mix of the world, and here the electricity mix in Brazil, since we are here. And how we produce electricity. Coal, sorry, it's in Portuguese here. Coal is 35%, hydropower 16%, and natural gas 23%. So in Brazil, the electricity, more than half the electricity we produce is from hydro energy. We have great hydro plants like Itaipu, etc. But we use also other sources, solar, wind, biomass, natural gas, and so on. But this is electricity. Electricity, as we saw, just a tiny part of the energy we produce in the world. So if we see the energy mix in the world and in Brazil, this changes a lot. For instance, in the world, coal is responsible for 1/4, natural gas, oil, petrol. Is 3/4 of this are produced from fossil fuels. I mean, even in Brazil, complete energy production, 11% only is produced by hydropower, from derivatives from sugarcane, 16%, and with a lot of oil also. Siderurgy, steel plants, for instance, use a lot of power. So each country has a different story to tell in this scenario. So that what is often spoken is what alternative forms of energy production, green and not so green. Not so green, I include here nuclear power as a possible alternative. But a wind turbine is quite common today. An in-ground one wind turbine produces 2.5 to 3 megawatts, which is more or less equivalent to 6 million kilowatts hour per year. An offshore in the sea wind turbine produces roughly the double of that. But the point is, there is not wind all the time. So on average, a wind turbine produces 35% of energy of the time. Solar panels, the present day solar panels, of course, there are developments being made today, but a typical solar panels has a 20% efficacy. That means that we receive 1,300 watts per square meter above the atmosphere. A third of that is reflected back. So in the ground, we receive 1,000 watts per square meter. And only 20% of that we can transform in solar energy, electricity, using a solar panel. That means a typical solar panel produces 200 watts per square meter. This varies according to geographical locations. 300 watts for a very sunny location, Brasilia, for instance, and 100 to 150 watts per square meter, let's say in Scandinavia, Siberia, Alaska, Canada. Well, nuclear energy. A typical plant produces 1 gigawatt for 2 reactors, okay? The largest American plant that has 3 reactors generates 4 gigawatts. Just to give. But then we have another problem. Uranium consumption presently in the world is 27 tons per year for 1 gigawatt. We have so 27 tons for 1 gigawatt for one plant. So the world has today 6.1 megatons reserves. For the number of plants, nuclear plants we have today in the world that operate in the world, this uranium consumption lasts for 90 years. If we double the number to replace oil or even coal, those reserves last 45 years only. If we multiply by 4 the number of nuclear plants, it will last 25 years. So we cannot rely entirely on nuclear power. We can use for some time, but well, not the source of generating energy is biofuel. For instance, in Brazil, we have ethanol for our cars. Hectare of land, that means 10,000 square meters, produces 7,000 to 8,000 liters of ethanol. And each liter produces 2.3 kilowatts of energy. Kilowatt per liter, kilowatt hour. Next problem, energy storage, because you see, if you have solar energy and wind power, you have sun and wind, they don't coincide with the moment you want to use the energy. You have solar power only during the day, but you also want to use energy at night. So you have to store this excess energy produced. So there are many ideas being exploited today, but this is a very complicated problem. You can pump water to higher elevations. You can fill a power plant and then use your gravitational energy to transform it in electricity or something like that. You can compress air. There were in the past some locomotives that function on compressed air. Because to compress air, you need to do some amount of work, and when you decompress, you recover that energy. Flywheel energy storage. It's essentially a wheel that you make it turn, you put energy there, and then you can recover it. So there are some chemicals and thermodynamicals energy storage. For instance, when you have a glass to molten an amount of ice, you can put energy there and try to recover, but that's the main idea. You have rechargeable batteries, like cell phones, that last only 2 years, and they have to recycle. And this is a very complicated problem. For instance, electric cars, when they do not explode, they last for 3-4 years maximum. You have to replace them. It costs a lot of energy. Then you have to recycle. There's hydrogen production. Hydrogen is interesting because if you burn hydrogen, it only produces water, not CO2. So you can burn hydrogen and drink it after, for instance. And there are many proposals of energy storage, which is very important for this green transition, but I say there's much development necessary in that direction needed now. Now, let's say how many energy the world consumes. So I put here the only electricity, which is roughly a quarter of the energy consumption in the world. This is in terawatts per hour. 1 tera is 10 to power 12 is 1,000 billion. Okay. So we have some typical countries. From China, it consumes 8,000 terawatts, of which 69% comes from fossil fuels, 26 are already renewable energy, and 4.9 from nuclear energy. USA has a different balance. We have here Brazil, okay, which is staggering 76% of renewable, and the world. So roughly 2/3 of the energy, electric energy produced in the world is from fossil fuels, 20% from renewable sources of energy, and like 12% from nuclear power. This for electricity. The total energy production in the world is a much higher number. It's 172,000 terawatts hour of energy, 27% from coal, 53% from gas, natural oil, only 30% renewable, and 7% nuclear. So it's only a fraction of that is consumed by electric energy. That's something we have to also remember. But just as an exercise for start thinking, I prepared this simple math, is what we need to replacing all non-renewable sources of electric energy by some renewable sources. That's considered by USA. They produce for 300 terawatts hour of electric energy. So 68% of that is from non-renewable sources. That give us roughly 3,000 terawatts of hour of electric energy. This is equivalent to 500,000 onshore typical wind turbines. That means one turbine at every 2 kilometers all across the United States, including forests, mountains, lakes, Alaska, and so on. Oops. Solar panels, almost 7,000 square kilometers of solar panels, or 343 typical nuclear plants, which the US has already 92, or 17 Itaipu dams. It's the biggest one in Brazil, one of the biggest in the world. Or if you take a typical American hydropower using a plant, is the Hoover Dam, the famous. You need 516 of them. Roughly 10 Hoover dams per United States state. It's a lot of things. China, if we do the same math, they need almost 1 million wind turbines. That means, since China is a big territory, 1 wind turbine every 3 kilometers, or 13,000 square kilometers of solar panel, more than 600 typical nuclear plants, or 48 Itaipu hydropower dams, or 26 Three Gorges dams. Three Gorges Dam is the biggest hydropower dam in the world. So it's not just for electricity. You see, it's not Brazil. Well, for electricity, we are a little bit better. Only, well, this number is wrong. It's 1,000, yeah, 1,000, which means 1 at every 7.6 kilometers, including the Amazon forest. 2,000 square kilometers of solar panels. This is bigger than Federal District, which we are here now. 100 typical nuclear plants. We have 2, I believe, now, and 7 more Itaipu dams. But Indonesia and South Africa is not very different. So we see that this type of renewable energy for the current electricity consumption is already some staggering numbers. And I don't speak about the rest of energy consumption. So it's not it's a very complicated situation, I believe. Also, cars and trucks, they consume energy. So I take here as an example the case of Brazil. Current production of ethanol in Brazil is 15.5 billion liters. In the consumption of oil for gasoline is almost 20 billion liters by year. And for the same efficacy, it can be replaced by 28 billion liters. So we have to triple the current production. So, the sugarcane require cultivated area is today's 5.5 million hectares. Is 70% of the current cultivated area by soy. So if we can produce all this amount of ethanol, it's possible for Brazil. Only a little increase in the area that's already used by sugarcane. Diesel also can be replaced by biodiesel. And the current consumption in Brazil is roughly 5 times that of gas for cars. So 60 gigaliters of diesel in 2022 and 6.2 gigaliters of biodiesel, which is already used in Brazil. It's 10% of the total consumption of diesel. 1 kilo. We did a little bit less than 1 kilo of soy per 1 liter of biodiesel, is 0.88 kilo to produce 1 liter of biodiesel. So an average productivity of 3 tons per hectare. This gives 26 million hectares. And today, total soy area cultivated is 76.6 million. So we could do this with a fraction, 1/3 of what is already produced in Brazil, which goes mainly for export. So this is, but this for cars, trucks, and electricity. We have the other types of energy that we consume. Another problem we have is we need to mine ore. Because if we produce solar panels, for instance, they need silicon. This photo is an example of a mining company that acts here in Paracatu. It's 100 kilometers roughly from Brasilia. It's a mine of gold. And here is also the water they use in the process of producing gold. And here is the city of Paracatu. So it's an example of the impacts of mining in how we say in the environment. Is not something small. And to produce green energy, we need to fabricate wind turbines, solar panels. Wind turbines is a lot of cement, which emits a lot of CO2 also. You need steel, and you need silicon, and you need other materials. And we have to consider this in this transition also. No, sorry. For instance, just to give also an example of math we must do. Photovoltaic cells that we use to make solar panels are made of semiconductor materials from the photoelectric effect. By the way, the photoelectric effect that gave the Einstein the Nobel Prize, not the theory of relativity. Just a curiosity. And we need silicon to produce polysilicon plus silver, aluminum, and copper. So we will need a lot of that. Yeah? For instance, today already 12% of all silicon produced in the world is turned into polysilicon for solar panels, which is already just a small amount of electricity production. And for that, we need very high temperatures in the production. And to obtain very high temperatures, we use coal. Yeah, that's another problem. And China is responsible for 77% of it, mainly using coal for heating. We can also think other ways, but today is the main way to obtain very high temperatures. Then solar panels consume 10% of raw production, roughly, of silicon. And when we reach more green future as planet, it will consume more or less 50% when reaching 100% renewable energy production because of just for solar panels. So you can imagine we still will need silicon for computers and other stuff. What will happen? we'll have certainly a very high increase in prices. So there are other similar problems. Reserves of silver are 50,000 tons. At the present consumption, which is 30 tons per year, we are left with 15 years of silver in the world only. Well, copper is a problem. We have a lot of copper, but the production is limited by each year. Batteries also require lithium, which is limited. So we'll need certainly some kind of recycling and circular economy for all these materials. Very soon, very, very soon. We can also, another solution I spoke is carbon capture. We can build some plants that capture carbon. There are today some plants in the world. We have 35 commercial facilities. There's carbon capture used in storage. Today we capture 54 megatons of CO2 per year using these 35 facilities. But the emissions are 37 gigatons per year. So today we capture 0.1% of all carbon we produce each year. Plans, the projects by 2030 is to have 200 new facilities. Maybe we can capture just 1% per year. But these facilities has an interesting advantage that it can use them to produce hydrogen, and hydrogen they can use to produce energy. So it's another path we can follow, but we see that the numbers that we are dealing with these green transitions are quite impressive. And before finishing, I'd like to remember that the 17 United Nations Development Goals, these were intended to be reached by 2030. I personally don't believe that this will happen so soon, but we see that climate action is one of them, and affordable and clean energy also, but they are all interconnected. And it's my very profound belief that we cannot reach one of them without reaching all the others. So I think we have a very hard task behind us, for us, our children and grandchildren. So just to conclude, that I try to just show some numbers for us to think, but green transition is far from simple. And I think it will require a complete redesign of present-day economy. The concept of constant growth, try to show it's incompatible with a simple fact, which is the planet is just one, and its size doesn't change with time. So the natural resources are already close to being depleted. And we're changing also the climate of the planet, and therefore making our lives here more miserable, which is, I think, is a serious problem. The green transition requires also new knowledge, more innovation in a quantity never seen before. And it's also interesting to see that the military in the world consumes 2.23 trillion US dollars each year, and research and development 1.7. So it seems that we are more prone to kill ourselves in different ways, in wars, in bad weather, in the depletion of natural resources, than trying to get us out of this hole. Also, you must remember that green energy requires a lot of mining that has also important impacts that you will have to administer in the future. Well, economic impacts, as I say, I think that's are huge. Another thing, science doesn't do miracles. We don't have, no science always find a solution. This is sometimes, but not always. For instance, many people speak about fusion power, which is having some important advancements, but I cite here a recent work in 2021 that Although prospects are undeniably exciting, commercial fusion in a decade is overly optimistic. So I don't, probably in 20 years we have fusion power. Maybe, it's not sure. So it's a very dangerous bet to expect for that. Okay? So in current trends, the world will exhaust oil and other minerals in just a few decades. As for oil and natural gas, or supply will not follow the demand, like copper, lithium, cobalt, which is important. So we need energy, that's the word. We need energy desperately, and while keeping the planet livable. And thank you for the attention.
Thank you very much, Professor Tarcísio Rocha Filho, for excellent presentation that not only explain the current climate crisis, but also provide us with several alternatives, forms of energy production and mitigation policy. So thank you very much. And now we move to Professor Guarini.
Okay. You can hear me? Okay. Then thank you so much for the invitation. Thank you to Jose Oreiro, and we collaborate together, but we are a very original mix of competence and fellowship. Please. Yes, yes. Yeah.
I hope I'm wrong. Really.
And okay, I start my presentation. Yes, but you stay. I would like to stay. I prefer stay up, but okay. Okay. Today is terrible. Yeah. Okay. You hear me? Perfect. Okay. My presentation focused on policy coordination to avoid global catastrophe. Okay. Sorry. Okay. Okay. Stop. Policy coordination to avoid global catastrophe. Difficult, but not impossible. After the presentation of Tarcísio, it's difficult to answer, to say something. But I think that this is the difference between natural science and social science, in the sense that there is a famous political Italian politician that say that the pessimism of reason and the optimism of the commitment, and social science, like political economy, is a mix of reason and social commitment, that we try to say something of optimistic, but I think the idea to have two different perspectives represent probably the nature of the problem, and about environment and ecological issues. Very difficult to face with these ecological challenges, because we should learn to interact between disciplines, like in this case, that probably one of the point could be the assumption is the discipline coordination, no? Because nowadays we suffer of a sort of fragmentation of the knowledge, also at university, but not only at university. Then it could be a good exercise to speak about environment that is a physical problem, economic problem, political, and so on. Okay, before I speak about policy coordination, that is necessary but complex, a sort of macroeconomic introductory analysis that I will speak about European Union policy coordination, lights, and showed out some example of initiative of coordination. that the first part could be more conceptual and come from our study with Jose. The main point that I want to underline that macroeconomic analysis does not face with the ecological issues, that the people can consider probably environmental issues for macroeconomic, probably for PhD courses, but not undergraduates. That it is a very paradox because environment and climate change represent the actual current challenge. Now, the first is the sort of the eco-Keynesian cross that we are aggregate demand and the income, and we can present this very simple version of the environmental identity. H would represent environmental impact. Now is not important which kind of measurement. We can say environmental impact, Y is GDP, and then we can represent H as a product between the pollution intensity and the GDP. The first point is that we used to consider the Keynesian cross. The second graph present, obviously in this case, optimistic because it's a line, not an exponential curve, but okay, that's not the problem. But in this case, this is a sort of green side of the Keynesian cross. The green side is that we want to increase Y, but we also increase pollution. But the point is that eta could represent the environmental efficiency, that the inverse of pollution intensity. We can consider eta at the macroeconomic level as the product of the ecological structural change. Obviously, this kind of analysis is static, but we can approximate all dynamics concerning ecological structural change with the increase of eta, the increase of environmental efficiency. The second point is that with the environmental issues, macroeconomic also should change the perspective, in the sense that before environmental challenge, we are not used to consider target approach in terms of a specific green target that we have to achieve. Or now we say that, okay, public spending is amount of million, not our target is increase number of students and so on. We start with the SDGs, in Europe start with the European cohesion policy, but also macroeconomic have to consider targets that are not only the fiscal target that we are used to consider. That in this case, only we consider an example of a green target, one level that we can consider sustainable. And in this case, we try to represent two possible alternatives to achieve this kind of target. One is the growth, a restrictive policies that decrease Y, that could be represented by point B, that we achieve the green target, but by reducing GDP. The other alternative could be increase Y, that increase GDP, but increase the environmental efficiency, that stress the role of eco-technological progress, that we can achieve point C. We obtain the green target, and at the same time we can increase our we have an expansive fiscal policy. The point is that with the environmental issue, if we want to consider environmental issues within macroeconomic, we start to use the term efficiency, that generally we don't use term efficiency for when we speak about macroeconomic. In this case, environmental challenge entails to consider a new form of efficiency, in this case, ecological efficiency, that a sort of green constraint for expansive policies is to go within the fiscal policies and ask fiscal policy for what? Not do the content of the green content of fiscal policy, but pay attention because could be the rebound effect. rebound effect is that the political coordination is essential, but we have to organize very well coordination, in this case, between fiscal policy and industrial policy, eco-industrial policy that incentive environmental efficiency. Why? Because if you consider green investment, private investment or public investment, they are two different sides to consider investment. One side is very traditional, no? Income multiplier, and the other is the green impact of green investment. But we are not sure that the net result is positive for environment, that we can have this sort of green macroeconomic failure, that we invest, we apply green investment, but the income multiplier effect is higher than effect on environmental efficiency. And this graph want to represent in an easy way this other problem. There is a problem of coordination, macroeconomic coordination, and we can also consider other kind of rebound about consumption and so on. But in this case, I want to consider investment like the crucial variable for macroeconomic export. Another point about the complexity is potential ecological trade-off. In this case, we use a simple three-equation model. We have aggregate demand in the sky and the Philip curve in red line. We are in the middle because always we are in the middle. We have in the right the social sustainable income, probably an income that is sustainable in terms of employment, but in the left we have given technology. In the left there is the income that is sustainable in environmental terms. That what we should do, I don't know. In this case, this is an important trade-off. And one example of sustainable and inclusive development policy strategy is to use the fact that a fiscal and industrial policy coordination that stimulate ecological structural change can reduce Philip curve, because in this case, we can have a positive impact of energy efficiency, and energy efficiency. We have to insert energy efficiency in the cost of production, that in this case, we can consider in the Philip curve. We have to consider in the Philip curve not only labor costs, but also energy and raw material costs. In this sense, we can maintain, we can reduce, we can shift to the right the Philip curve, aggregate demand increase, and at the same time, thanks to an effective ecological structural change, we can we allow to have more income environmentally sustainable. Obviously, it is a very optimistic case, but only is an exercise to say that we have to change our mentality also in the case of how we can address impact of macroeconomic policies. We have not to consider also demand side, but also supply side. In this case, supply side means energy cost, raw material input, that for us represent an approximation of which is our where we are in terms of energy transition and ecological transition. But there is another important case that in Europe and nowadays stress the political debate, is the energy inflation. That here in this is the case of very mainstream case, that there is inflation, that there is an increase of price, that the Philip curve shift to the left, and mainstream strategy of monetary policy of the central banks is to react by increase the interest rate, not try to come back, push to the right Philip curve. This is a very typical example nowadays in Europe, due to or thanks to, depends on the position of the European Central Bank. But now energy inflation has a different characteristic, or inflation caused by labor cost, because, for instance, energy price can be influenced by financial speculation. That could be a sort of fight of two different forces. One force is that believe in the restrictive monetary policy of the European Central Bank, but the other side, there is a force of expectation of financial speculation that stress rise the energy price to the high, up. That in this case, probably this kind of, I'm sure, but we can say probably the traditional mechanisms fail. That there are not mechanisms for environmental shocks like energy prices, energy inflation. We can consider then a case of anti-energy inflation strategy with policy coordination that some people ask for the European Central Bank, for instance, in this moment. Probably energy policy, energy inflation entails a change of strategy of monetary policy. On one side, he decided to reduce the aversion to inflation, that changed the slope of aggregate demand. But obviously, we can consider another aspect that could balance this, and the balance could be very strict, not with the monetary efficiency, but with the green efficiency, that in some cases stress and to the green finance. Also because we know that green investment are more sensitive than brown investment to the interest rates. Then an increase of interest rate not only reduce the amount of investment, but change also the share, the weight of green and brown investment in favor of brown investment, because green investment are more risky, uncertain, and so on. That this kind of coordination means, okay, I reduce my aversion, but I consider that you have to do some green strategy for private investment and public investment. That is the idea. To come back, flip to the starting point, or go to the right. Also, obviously, in this case, probably European Central Bank should fight with, in some cases, or moderate, mitigate the financial speculation. Okay, this is very important for energy transition. And finally, for this kind of conceptual section, we can consider international policy cooperation. In this case, I refer to an article published in Ecological Economics, but here I want only to present a very simple identity. In this case, only the change between from before is that we put the name pollution of the North country and pollution of the Southern country. Only with the little, because the devil is in the details, that in this case, only to put the pedix change perspective, because environmental energy transition, the fight to avoid climate change is also very political point, and political in terms of relationship between North and South. That complexity, because could be a trade-off between economic catching up of the developing country with green sustainability. That is difficult, this kind of trade-off, but the high road could be the eco-technological cooperation between, becomes essential to increase ecological efficiency in the South, that you have to increase, in this case, we try to increase YS, but also reduce the pollution intensity, but without technological cooperation is impossible. The second point is that considering green sustainability in the trade agreement between North and South countries should not mean only insert green standards, but also should means open the northern market to the southern goods generated by the ecological structural change. Otherwise, we have a sort of green protectionism. And this is the other important point, because we say the ecological structural change, but this means that you have to export not only raw materials. Otherwise, your goal is only to exploit natural resource. But to do so, to do this, you have to sell this good to also to the northern countries, that not the countries that open his market. Okay, this is the first point, conceptual section about the complexity of the policy cooperation, but also this is the only road to try to face with the climate change challenges. Some ideas about European policy coordination, lights and shadow. We consider general view is important that for Europe, starting from especially for Europe Strategy 2020 and after, even if there was the pandemic, COVID, but the general strategy is to consider three important targets: smart growth, that means increase economic growth, but also increase labor productivity. Inclusive growth means other kind of target about employment, about poverty, that we can synthesize with an increase of GDP, but also an increase of employment. And finally, sustainable growth, try to increase, to have a sort of decoupling. Okay, trade-off, new strategy. Here is a very simple dynamic identity that say that in the first one is income identity. GDP growth rate is equal to employment growth rate and labor productivity growth rate. In the case of employment, we have to be the growth of GDP higher than the growth of labor productivity. But at the same time, if you want to decrease pollution, we have to increase environmental efficiency more than growth of GDP. And in this case, now, if we come back to the Harvard, we can see that all these variables go along that could be impossible to have a solution, or we could think some mechanism. But this is the very general condition that is important to consider, that in Europe there are this kind of strategy, all these kind of pillars means different targets that change the mentality about, should change the mentality about policies. But these are regional policy, not macroeconomic policy. That is, I spoke after. Another kind of initiative is to in transition, not to combine the digital transformation with the energy transition. And there are various different studies that underlie the potentials of digital transformation to increase energy efficiency, the efficient use of energy resources, facilitate the integration of renewables into the grid, or save costs for consumers, energy companies. This could be the role of digital transformation, but it's important to connect these two kinds of challenge, digital and ecological. There are many documents of the European Commission about this. And this is another initiative of the European Union. Just transition means the mechanism that can refund regions that suffer from employment disadvantage due to energy transition. These are political initiatives. But this kind of strategy could be uncoordinated, or they could be conflicting. The first point is that probably only regional policies and cohesion policies in some cases are implemented in the mentality, in the approach, in the perspective, the ecological target and human development. The problem is that there is a sort of dichotomy between the regional policies and national policies, because national policies are target that are very different. Fiscal policies is focused on stability pact in austerity, and monetary policy is focused only inflation targets. And this is a very institutional imbalance with very difficult and negative consequence. Now, about fiscal policies, probably there are some light in the sense that, you know, that stability pact was stopped during the pandemic, but it will restart in 2024. European Commission present a proposal of reform about now in 26th of April about a reform of Stability Pact. The problem is that the core remain the same, change only the period, the time for the countries to achieve this kind of targets. But there is nothing about only someone says that probably some green investment could be out of the public debt. Otherwise, we speak about what? Because all of this kind of ecological transition need of a public expenditure. That if you instead consider only fiscal parameter, is impossible. That is not only a pessimism in terms of physical laws, but also in terms of fiscal rule. Someone said something, Mario Draghi, something was very surprised because in one of the speech said that there is good and bad public debt, but it was an informal speech. Yeah, but not the idea, introduce the idea that debt for what? No, that you can evaluate the public debt also in terms of which are the how you use the public resources. And then, for instance, there is some specific plan after the COVID, the next generation European Union, that in this moment also in Italy, there are public resources thanks to the resilience plan. The problem, how we can use this efficiently for ecological structural change. The main point is that, for instance, in the resilience plan, there is energy transition, but at the moment, energy transition is only considered in terms of energy sector, to efficient energy sector, not to help the productive system to make the ecological conversion in terms of technological transfer, in terms of incentives to change the mentality and the management of the firms. Okay, the other idea is about the fiscal parameters, and in all this kind of problem, there is the division, political division between North and South Europe. And then there is monetary policies, not after the Russia-Ukraine war start this problem of energy inflation. We can come back to the previous section. Only we can consider one point, interesting point, that Keynes, after the Second War, proposed a sort of stabilization fund for energy and raw materials prices. Probably this could be an important proposal for Europe, for instance, because we have institutions that could manage this kind of fund, and we are aware that in the future will be other kind of energy or raw material inflation influenced by financial speculation. That probably this proposal of Keynes could be very important to reconsider. I don't know the timing that I have time. 5 minutes, I don't know. Okay, you say like Italian. Yes or no? Yeah, you should be Spanish in this moment. No ambiguity, or yes or no. That some example of initiative. One initiative is interesting, no? Italian Alliance for Sustainable Development, because the colleague present sustainable development goals, but it is important to create at the national level some social political coordination to stress institution to implement the and to achieve the sustainable development goals, and also to adapt, because sustainable development goals represent very international strategy, but you have to adapt to at the local level. And this kind of initiative, I think, is quite interesting, because there are trade unions, there are universities, there are social associations, but perhaps there are all civil society, and some institution also research center that stress institution to go in the direction of sustainable development goal. And finally, 3 examples of open innovation policy initiative, in the sense that before we say that it is very important to connect three kind of a world, no? The business with the university, but also with the public center, that there is this kind of program, framework program for research and innovation that works very well. And some of these are focused on green transition in terms of innovation. We have studied this kind of initiative. This, for instance, is a graph that change the share, the participation of business, public center, and university in this kind of network. For instance, in Germany, blue sky, the best is business, represent the majority. In the case of, for instance, United Kingdom is the university. That change, but they are important, and we have some empirical evidence about the success in terms of green patent, in terms of the combination of, because science and technology knowledge, but also to achieve green target, we have to combine science and technology knowledge with doing and using knowledge that is characterize the firm's productive system. Then it's important the knowledge transfer within university and firms. Otherwise, it is not possible. And also, also is very effective the combination of regulatory policy with research. We said before, not only standard, but only capability to achieve this standard, otherwise impossible. The second point is an Italian example. Italian eco-business network agreements are only across firms that decide to present a project and to create a network with this kind of project. And this project is based on green innovation. Also, in this case, we have found very important technology, environmental technological spillovers. And okay, I have to finish. Only to say that another interesting initiative is energy communities. Means there are some internal areas that are without population, that are out of grid, and there are some initiatives to stimulate, to recreate community by organize, produce, and use energy, and renewable energy that can represent a way to revitalize some kind of local communities. Very there are important examples in Germany, but also in Italy about this. That I have only to say. Thank you.
Thank you very much, Professor Guarini, who provide us with the international perspective. And now we will open the floor for your questions. The first question from Professor Oreiro.
Well, I will make my question to Tarcísio. If I understood your presentation, the real issue is the following. Me and Guarini have a vision of ecological structural change that basically this. The problem is CO2 emission that is increasing the temperature enough. So we have to reduce the CO2 emission. In order to reduce the CO2 emission, we have to make the ecological structural change from brown technology to green technology. Okay, it can be difficult. Maybe the market is not capable by itself to do this transition because there are a lot of externalities, so on and so forth. So we need the state to induce this ecological structural change. Also, maybe we need some international coordination between countries in order to achieve the goals of CO2 reduction, but it's not an impossible task. Okay, we can solve it. So we can be some hope on the future of humankind. But what you're, under my interpretation, what you're saying to us is this. Okay, there is a green technology, but in order to to make this transition from the brown technology to the green technology, you must use natural resources in a pace that will exhaust these natural resources required for this ecological structural change in 20 or 30 years. So we are between the sword and the cross, you know? If we do nothing, will be that the climate change will simply exterminate human life in the next 100 years. But in order to try to do something, we will be run out of the natural resources that are required to do the ecological structural change in the next 30 years. So what you're saying basically is that we do not have even a chance. It's my interpretation. Okay, it's a provocation. I want to see your answer.
Understand. Well, I think the task is very complicated. You want? Okay.
Because we might be saying related things. Thank you very much. This was both very interesting. I have two questions, but I'm going to address it to both of you, though with sort of different weights, probably, given how much emphasis you put on that. First, in terms of the mix of renewable energy, I understand you see a substantial role for nuclear energy. I mean, it is not renewable to begin with, but is it clean? Meaning, given the expected value of nuclear disaster, meaning a small probability of a leakage, but with totally deadly long run costs, do we really need that in the mix of energy in transition? And two related questions is, you have not talked about geothermal energy. So Kenya is actually producing a lot of its renewable energy using geothermal energy. It can be country specific, but my understanding also from Bob Pauline and colleagues is it is part of the mix. It should be. And last question is about biofuel. Does it fix one problem, but then lead to issues with food inflation? So is it sustainable really? And this last one is really a genuine question because there are different ways of producing it, I understand. Then moving forward, should we not think about green investment, particularly by the public sector, as things that could potentially substitute private consumption? And that brings me to my main sort of enemy, electric vehicles. Is it more greenwashing? And instead of electric vehicles, private electric vehicles, like let's replace all cars with a private electric vehicle kind of attitude? Should we not move towards ways of public investment en masse, such that people don't feel the need for having a private electric vehicle? And if they do, it's a luxury thing and it's easy to, you know, tax it so insanely that we will substantially reduce the demand for electric vehicle. Obviously, major political economy coalition issues there between the private automotive industry, trade unions in that industry, and sort of a big public transport mobilization. Because my understanding about limits to growth means, well, we can't really limit it too much because we need massive amount of investment for green transition. Then something has to go. There are limits to what can be cut. Military spending, sure, lots of luxury consumption, lots of unnecessary advertisement that goes into all the GDP, but there has to be more behavioral change. And how are we going to induce that? And for me, you know, producing plant-based organic food with public subsidies, cooperatives, well, is one way of giving the chance to people not to consume that much beef. But these are two examples that I keep thinking, what can the public sector do in terms of investment in agriculture, in circular economy, in public transport to reduce private consumption of private electrical vehicles, meat consumption, and to consume less, but to recycle more. Having said all that, I'm not a degrowth economist, but I keep thinking, what can public policy do to substitute some private consumption? Because otherwise we're going to run into your limits of material availability sooner than we can do the transition. Anyway, these were half questions for half comments, really. Thank you so much.
Because we are running out of time, there is someone.
Thank you very much for the presentation. For me was great, and it's a very important topic. So it was very useful for us. So for me, there is one point that you raised that is that the green transition means minerals that maybe we don't have enough, and also it has environmental problems. So what I get from your presentation is that in order to get to a point that the planet is sustainable, we need to rely in innovation, not in the technology that we have now. So, yeah. But the question is, do we have time to that? What do you think?
Well, I try to show that we have limitations today, but I strongly believe that we need a lot of innovation and developments that many are already on the development now. For instance, new materials for building solar panels, more efficient, that require products that are easily available. So we have to invest a lot on this. With present technology, we have in a very difficult situation. But we can develop new technology. For instance, the example of fusion energy, which is not for 10 years, maybe 20 or 30, it's difficult to say. But this would be a game changer, of course. But it's not possible now. Then I think this green transition will be made in different steps. We start with current technology and we evolve from that. But the point is, if we continue as we are now, we are doomed. Maybe not us here, but certainly our sons and grandchildren. Well, if you see oil will be depleted, let's say in 40, 50 years, if we don't have any more oil in the planet, well, I think that we have a very serious economic problem. So what we expect that the prices of many commodities will rise strongly very soon. But oil, petrol is already very high. I remember that when I was a children, we used gasoline to clean the garage, for instance. We don't do this today. Prices are much higher now. So we are already suffering the consequences of these limitations. But I think, as you Jose asked, we can do this green transition, but it's not so simple or so obvious. We'll have to plan this. And this transition will take decades. It's not something, and we'll have to start now. We have to prepare to see different options. We need a mix of different technology of wind, of solar energy, maybe nuclear power. It's an alternative, but it will not last forever neither, because uranium reserves are finite. As we see, a nuclear plant produces a huge amount of energy. But we have security concerns, which I don't believe are very so worrying if we compare with what oil production causes in nature and human life. But it's already also a problem. They have a problem. So we have to weigh the advantage and disadvantage of each options and have different solutions. In each country, we have different solutions. Iceland certainly will rely a lot on thermal energy. Brazil, not so much. but we'll have to rethink a lot of things. And the energy consumption industry, our industry, uses a lot of energy. What we will do? So I think the solution is complex and technologically it's challenging. We will have to invest a lot on innovation in this sector, much more than we're investing now, a lot of money, to hope to produce the technology that is required for a better future. And we have no other choice for me, because if we follow current path, we will have an economy, I would say, civilization collapse in half a century, something like that, because the problems are very different. So the way we build current economy in societies is done. It will work maybe 10, 20 years, but not much longer. And we have to transition to something different. And this requires a lot of thought, planning, and mentality change, politics change, and is a very big challenge. It's possible, but very difficult. That's how I see it. I think if we plan correctly and invest correctly, it's possible. But we must start now and plan correctly. It's difficult because the problem is not simple. That's the way I see it.
I only want to say that generally I think that the degrowth approach is like a mirror of growth approach, that they don't go within the process and they do not analyze, they not discriminate which kind of goods, which kind of service. That is the first point. The second point is that if we go in depth, we can say that it is not possible to have energy transition without a sort of public expenditure, because we can also, to reduce consumption or change behavior or consumption, you need public expenditure in terms of public campaign to convince people, or a sort of project in the school to educate people, for example, for about circular economy, no? And then I think that in this case, there is a sort of a complementarity between public and private investment, private consumption, and public expenditure in general. Obviously, can be the risk of privatization of energy transition. That for this case, I think that for energy transition, we should rethink about the role of state in some specific sector, like transport sector, like energy sector. Because if you consider in Europe the difference capacity to react to the energy inflation between a country like France that decide to renationalize the energy sector, instead of in Italy that this not happens, no? Change the ability to react, that we also to consider this kind of aspect. And finally, is also important to put this kind of the use of public expenditure for energy transition in the efficiency way, in the sense that two important examples for Italy. At the beginning of 2000 was a massive subsidies for solar panel, but this create a sort of speculation that entrepreneur decide not to invest in technology of solar panel, but buy from China. That now we have only Chinese solar panel. Instead, we could invest in technology because it's possible. It's a closed door, but there is space to invest in a high level of technology. I think in Sicily, there is a firm that invests in this. Not that this could be this kind of a sort of failure to capture the opportunity to change. And another case in agriculture, my university is in the north of Rome, Tuscia. That is close to Tuscany. And you know Nutella? Nutella is quite famous in the world. Okay, the nuts of Nutella come from the North Piemonte, some in Turkey, but very much from Tuscia. And this very is good for farmer, but they change the production to monoculture. And that's a very important problem of ecological, in terms of ecological perspective, which is the reaction of the public sector is to subsidy the biological agriculture. But you know, you receive a subsidy to cultivate nuts, but you need for 5 years to obtain nuts to sell to Nutella, okay? And generally, entrepreneurs obtain this subsidy for the 4 years. The 5th year, they decide to change kind of production and to come back to the standard agriculture. This kind of subsidy is a failure. Now that there are many possibilities to speculate in public subsidies or in general in green public investment, that is important to create a strategy also in this sense.
Do we have other questions? No? Okay, so with that, we will close today's session, and I would like to thank you, Professor Bongiappilli and Professor Guarini, for excellent presentation, and thank you also for the audience.
Well, people, just remembering that tomorrow we will start the ordinary section at 9:00 a.m. At 11 o'clock, there will be our second keynote lecture by Professor Carmen Feijó from the Federal Fluminense University. And I would like to use this time to many thanks Oslin Onaran that with his generosity came to Brasilia, but she will go back to England tomorrow. So many. Oh, okay. Oh, many thanks. But Onara, many thanks for your came here. It's really an honor. Okay, so people, let's finish for today and see you tomorrow. Bye-bye.